Hey everyone, for two parabolas, y squared equals 10x with focus F and y squared equals negative 4 times x minus 6 with focus F prime, P is one of their intersection points. Also, the length of PF is 8. We're going to find the perimeter of PFF prime of the triangle. Alright, so I drew a little picture here. And I probably got ahead of my skeets a little bit, but let's go ahead and look at this. If we have y squared equals 10x, and that means we should write this as 4 something x, right? So to get a 10 here, this is going to be 10 divided by 4. That means my p is going to be 5 divided by 2. Therefore, your focus equals 5 halves, comma 0, and your directrix is x equals negative 5 halves. All right, now let's do the second one. This one opens up to the left because we have the negative. So basically, if we look at y equals negative 4 x, and compare it to, this is y squared. Y squared equals negative 4x minus 6. This is basically a translation of 6 units along the x-axis. So for this one, if you have this and write it in standard form, like y squared equals negative 4 times px, that's going to be 1. So, or negative 1. So our p equals negative 1. That means the focus for this one is going to be, let's see, negative 1, comma 0. And our directrix would be x equals 1. But we have to translate it. So basically that means our new focus is going to be right negative 1, 0, and you're going to have plus 6 here. So this is going to equal 5, comma 0. And then your directrix is going to be x equals, we have 1 here, but we have to add 6. So our directrix is x equals 7. And we have that there. Okay, so once we have that, we're going to find the perimeter of PFF prime. So basically, let's suppose, and I have this here with the triangles, we have these H's here. So suppose H, line segment H prime, this right here, is perpendicular to the directrix x equals negative 5 halves and x equals 7. Then by definition of a parabola, that means that PF equals PH. So these two equal, right? You take some point on the graph and the length of the point to the focus is the same as the length to the directrix. And also for the other graph, we're going to have PF prime equals PH prime. Same reason. So I put 3 ticker marks here because those are the same. All right. Now let's go ahead and add some of this up. There's our little triangle there. This is the triangle PFF prime. This triangle right here. So PF plus PF prime is going to equal PH, since they equal, plus PH prime. And this is just going to equal H times H prime, right? This line segment here. And this is going to equal 7 minus a negative 5 halves. So I'm trying to find this whole length. So I'm just looking at the directrix. and that's going to equal 19 divided by 2. And let's see what else. We want to look at f prime. Let's do that before we move on. This length right here. This length right here, remember our focus was here. So that f prime, you just subtract these two. So that's going to be 5 minus 5/2, which equals 5/2. All right. So now that we have that, we're just going to add up all the sides. We have all the sides here. So this is going to equal PF plus the length of PF prime plus the length of line segment F prime. So basically this is just going to be 19 divided by 2 plus 5 divided by 2, and this is going to equal 24 divided by 2, which equals 12. So that's your perimeter of the triangle PFF prime. And that's it. Thank you. Have a nice day. Bye-bye.